Now we look at a fast way of dividing polynomials where we can avoid long division, but to use synthetic division, we need a divisor that looks like x plus or minus some constant, and that's it. Notice that this is x to the first power, not x squared or x cubed. It's got to be x to the first power plus or minus a constant. Let's look at this in action. Let's divide 3x to the fourth minus 2x squared plus 5 by x minus 1. And we can see that x minus 1 is x minus a constant, so it falls into this category. Now the cool thing with synthetic division is we don't have to write any variables anywhere. We just focus on the coefficients. But the problem is, like if you look at this dividend, it's an x to the fourth polynomial. And so we have to make sure that we include every coefficient below the x to the fourth. And you can see this has no x cubed term. So when we write the coefficients of 3x to the fourth minus 2x squared plus 5, we get 3x to the fourth plus 0x cubed minus 2x squared plus 0x plus 5. So you've got your x to the fourth, your x cubed, your x squared, your x, and your constant. Okay, so that's your dividend. You don't write any x's here. Now you do want to make sure you get your negatives. When you've got a negative coefficient, you need to carry it along. Now the difference in setting this up from long division is you invert the division symbol. So now you do this instead. Okay, and to write your divisor, x minus 1, this is the trickiest part here. So I'll put a star next to this. X minus 1 goes out here, but because we know it's going to look like this form, x plus or minus a constant, we don't actually, all we put here is the 0 of x minus 1. So the 0 of x minus 1 is positive 1 because positive 1 is what you'd plug in for x to make this 0. Okay, so that's the setup for synthetic division. Let's set up another one side by side so we can kind of run through the same process. Let's say we want to divide x cubed plus 8 by x minus 2. So to set that up, we'd have 1x cubed plus 0x squared plus 0x plus 8 for our dividend, divided by the 0 for x minus 2, which is positive 2. So that's the setup. Let me put a line between these just so we understand we're doing two separate problems sort of simultaneously. So, a couple things to note. You want 0 placeholders, and you want to use the 0 of your divisor. So you use the divisor's 0. Okay? Alright, and then the process here to get started. So you make two empty rows. One empty row right under your dividend, and then an empty row under this line. So we're creating this line. And then I always like to put a box here in the bottom right entry of my bottom row. Okay? So we're going to set it up like that. Now to get started with the process, you simply drop your first coefficient all the way to the bottom. So I'm going to drop the 3 here, and I'm going to drop the 1 over here. So we drop the first coefficient. And then after that, you start this process of multiplying and adding. So you multiply and you add, and you repeat. So you multiply and add, and then you multiply and add, and you just keep repeating that until you're done. So let's get started. You always multiply by the divisor. So 1 times 3 is 3. And then you add vertically. 0 plus 3 is 3. Now you start over. multiply your 1 times the new 3, which is 3, and then you add vertically. Negative 2 plus 3 is 1. Then you multiply the divisor. 1 times 1 is 1, and then you add 0 plus 1 is 1. 1 times 1 is 1, 5 plus 1 is 6. We'll talk about how to interpret this in a second. Let's repeat the process over here. We've already dropped our first coefficient. Now we start multiplying and adding. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 8 plus 8 is 16. Okay, so what do we have here? What's the result telling us? So now we do all of our work without the x's, but in the end we have to turn all this back into polynomials. So the fun part's over. Pretty easy if you can do basic arithmetic in your head. Now remember, this first term over here was 3x to the fourth, and the first term over here was x to the third. When you divide in synthetic division, because you're always dividing by x to the first, the result is going to decrease the degree by 1. So if I divide 3x to the fourth by x to the first, I'm going to get x cubed. So this term down here, my first term is x cubed. Over here, my first term is x squared. Okay, so we're putting the x's back in. And then you know now what your first term is, and you're not missing any terms, so you know that you just go down by a degree of 1 every time. So this would be 3x cubed positive 3x squared, so this is our x squared term, plus 1 x to the first plus the constant. Okay. Similarly, over here we have 1x squared plus 2x to the first plus the constant. All right, so what do we have? Now, we have our dividend up here. We have our divisor here. This guy, the answer that we get is our quotient. So this is our quotient over here. And then what's in the box? Why I like the boxes, that's our remainder. Okay, so now we can use this to do a couple things. We can say, all right, well, 3x to the fourth minus 2x squared plus 5 divided by x minus 1 equals the quotient 3x cubed plus 3x squared plus x plus 1 plus our remainder 6 over our divisor x minus 1. So this is q plus d over r. All right. Over here, the similar result would be, let me extend this line real quick. I erased it so I'd have enough room there, and then of course now I need it. We'd have x cubed plus 8 divided by x minus 2 equals a quotient of 1x squared plus 2x plus 4 plus our remainder over our divisor x minus 2. Okay? Or we could use this result to break down our dividend. So over here we could say, well, 3x to the fourth minus 2x squared plus 5 equals the divisor, x minus 1, times the quotient, 3x to the fourth, 3x to the third, plus 3x squared plus x plus 1, and then add our remainder plus 6. If you multiply all this out and add 6, you should get this original polynomial. Okay, so that's another way you could use the division, is to break down your dividend. Similarly over here we could say, well, x cubed plus 8 breaks down to be x minus 2 times our quotient, x squared plus 2x plus 4 plus our remainder. Okay, and that is synthetic division. Let's do one more just to really get a handle on this, and we'll call it a video. Let's divide negative x to the fourth plus 5x to the third minus 2x plus 3 by x plus 1. Our dividend is negative 1x to the fourth, positive 5x to the third, 0x squared, we're missing an x squared term, negative 2x plus a constant of 3, divided by the divisor, which is the 0 of x plus 1. The 0 of x plus 1 is negative 1. Again, be really cautious about that. That's what everybody messes up naturally, right? So it takes practice. You have to work to remember that. And you start the process by dropping your first coefficient all the way to the bottom. And then after that, you multiply and add. Negative 1 times negative 1 is positive 1. 5 plus 1 is 6. Negative 1 times 6 is negative 6. 0 plus negative 6 is negative 6. Negative 1 times negative 6 is positive 6. Negative 2 plus 6 is 4. Negative 1 times 4 is negative 4. 3 plus negative 4 is negative 1, and that's our remainder. So, negative x to the fourth plus 5x cubed minus 2x plus 3 divided by x plus 1. If we divide that, we get a quotient of, well, this was x to the fourth to start with. When we divided, the degree goes down by 1, so now we have x cubed. So this turns into a quotient of negative 1x cubed plus 6x squared minus 6x plus 4 is our quotient. Our remainder is negative 1, so I'll say plus negative 1 over our divisor, which is x plus 1. Or we could use it to break down our dividend. Negative x to the fourth plus 5x to the third minus 2x plus 3 breaks down to be our divisor, x plus 1, times our quotient, negative x cubed plus 6x squared minus 6x plus 4, plus our remainder, negative 1. And that's our final example of synthetic division. Hopefully you like that. It's much simpler than long division, but it's also restricted because you can only divide by divisors of a certain form.